Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the reaction type. The reagent K plus TBO potassium tert-butoxide is a bulky, strong, non-nucleophilic base. Under E2 conditions it promotes elimination. Moving on to the next step. Identify the substrate structure. The central carbon bears 4 different groups: CH3, PH, CD3, deuterated methyl on wedge, and Br on dash. This is a tertiary-like carbon, but more precisely it is a carbon with PH, CH3, CD3, and Br for E2 elimination. The base removes a beta hydrogen or beta deuterium antiperiplanar to the leaving group, Br. Moving on to the next step. Determine what beta hydrogens deuteriums are available. The groups attached to the central carbon are PH, CH3, CD3, and Br. The CH3 group has 3 H atoms, beta hydrogens, and the CD3 group has 3 D atoms, beta deuteriums. E2 elimination requires antiperiplanar alignment of the beta H or D and the Br. And for the final step, determine the product. E2 elimination removes HBr or DBr from the substrate. The central carbon loses Br and a hydrogen or deuterium from either CH3 or CD3 is removed. This generates a double bond between the central carbon and either the CH2 is equal to from CH3 or CD2 is equal to from CD3 carbon. The product is an alkene, PHC, is equal to CH2, CD3 or PHC is equal to CD2, CH3. Assess chirality of product. The alkene carbon that was formerly the stereocenter is now sp2 hybridized, trigonal planar. An sp2 carbon cannot be a stereocenter. Therefore, the chiral center is destroyed upon formation of the double bond. Evaluate the options. A. Inversion implies the stereocenter still exists, but with opposite configuration, not applicable since the stereocenter is gone. B. Retention implies the stereocenter still exists, with the same configuration, not applicable. C. Racemization implies equal mixture of both enantiomers, not applicable, there is no chiral center at all. D. Loss of chirality, product is achiral, correct, because the sp2 carbon in the alkene product is no longer a stereocenter. Therefore, the correct answer is D. Therefore, the correct answer is option D.